Yaskawa.
In this video, let's look at how to use the parameter setup wizard to solve a speed mode application for the analog pulse version of the Sigma 5. So here's our application story. It says a machine tool customer has a proprietary motion controller that positions a vertical axis by sending a speed profile to the servo. And that range of the controller command will be plus or minus 10 volts. You can see here in this picture, the controller is sending plus or minus 10 volts to the amplifier, and the motor should have a speed range of plus to minus 3000 RPM. It says the maximum encoder feedback resolution is necessary. That's the encoder feedback coming back from the Sigma 5 back to the controller. The encoder is to function as an incremental encoder, as the controller is using a homing routine, so they don't need any absolute functionality for the absolute encoder. And the controller uses a manual override mode that activates a single output. I have that shown here in this simple drawing. Manual override is supposed to limit the torque. So there's an input we'll use in the Sigma 5 to limit the torque to 10% in both directions. If any of the torque limits are reached, the amplifier should turn on an output. So see, we have an amplifier output here that would be used for torque limit, and that then could be used wired back to the controller input, so the controller can tell if it's hit the torque limit or not. This is a vertical axis that uses a holding brake, and we'll be controlling the holding brake through a relay connected to the output SO1, here pins 25 and 26. And finally, this is a vertical application, so if the motor hits an over travel, we'd like it to stop with maximum torque. And I'd probably add, leave the motor enabled if you hit the over travel rather than disabling the motor. So here's what we'll do. We'll follow these instructions. I'll initialize the parameters. I'll use the setup wizard to set those parameters, the setup wizard and the parameter editor. I'll label these terminals here in my drawing. At some point, I'll look at my parameters that were changed, and I'll also verify operation on the demo. So I'll start here in Sigma Win Plus and go to the parameters screen. And down at the bottom, initialize to factory default. Okay, and that's it. Now I don't have to cycle power right away. I'll just go ahead and do the parameters within the setup wizard. So I'll start with my encoder selection that I'm not using the fully closed encoder. Now I'll choose my control mode as speed control and apply that. Next is the reference input setting, and the application states that we'll have 10 volts commanding 3000 RPM. So here I have 3000 RPM, min minus 1 is RPM, and I'll do 10 volts from the controller. That calculates the parameter for us. There was no mention of a speed coincidence or VComp output, so I'll click next. There was no mention of any acceleration times, so we'll just leave those at default. And onto motor encoder setting. This is the number of pre-quadrature output pulses per rotation, and it says here in my application story that we need the maximum within the given speed range, which is 3000 RPM. So the maximum speed is limited by the output value of the resolution. And so since I'll be using 3000 RPM, I see the maximum there is 32,768. I'll also see here it says use absolute encoder as absolute or use absolute encoder is incremental. So I'll choose incremental, as it says here that the encoder should be used in the incremental mode. There was no mention of reversing the direction, so I'll leave this at default, and that completes the encoder setting. Now onto motor stop. Our application did call for that when we hit an over travel, the motor should stop with 300% torque. So that means that back here in the over travel stop mode, I would set to the second one here to stop with the torque of parameter PN406, decelerate the motor to stop, and then use coasting. I'm sorry, I should use a servo lock state. Leave that servo enabled at the end, so you're setting number 1, and I'll have to go manually to PN406 later on. We also had said this was a vertical axis and that we'd use the brake motor setting, so I'll check that box and I'll hit apply. The final area is the I/O signal. So within the I/O signal setting, what do I need to do for inputs? I see that the servo has an input here on pin 46 for the manual override, and that will be tied to PCL and NCL on one terminal. So I'll go to the input signal setting, and here I've got all of my terminals and all of the functions, input functions for those terminals. And PCL and NCL were supposed to both be on pin 46, so I'll just move PCL over to pin 46 and click OK here. It's warning me that there's a duplication, and I did that on purpose, so I'll click yes. Here in the amplifier I have two outputs that have been specified. There was the output number 1, the holding brake relay, and there was output number 3, the CLT, the current limit or torque limit output. So back here in the wizard I'll go to the output signal setting, and it looks like I'm not using the default here on output 1. Instead I'm going to use the current limit output. Output 2 wasn't mentioned, so I can leave that one at default. But then output 3 was supposed to have the brake. Okay, actually output 3 was supposed to have the current limit output, and output 1 was supposed to have the brake. You can see the brake is required because I checked the box. And I can confirm that here for the I/O in this pictorial wiring diagram. I now hit apply, and I'll go ahead here and do save this parameter file called speed mode. And now I'll write here with a backup file, save that backup, and write into the servo pack. And now I can cycle control power. And do that. It says I should reconnect, so I'll do file, reconnect. And I've got a couple parameters that the wizard didn't hit. You can see here I had to set the override torque amount to 10%, and I also had to set the overtravel torque to 300%. So to set those torques, I'll go to the parameter editing again, and you can see there's a tab even for torque parameters, and the torque parameter associated with PCL and NCL are the forward and reverse external torque limit. So I'll set that here to 10 for the forward and 10 for the reverse. And then right below that is the emergency stop torque, which I said I'd set to 300%. So that's pretty much full stopping torque. And I can write those over, and no power cycle required for those three. So let's see where I am here on my instructions. I've initialized the parameters. I've used the setup wizard and the parameter editor. I think I got all of them there. How about I'll label these terminals now? The analog command is coming into pins 5 and 6. And how do I know that? I can look at the wiring check, and I see that the speed reference input is always pins 5 and 6. The controller will also have servo on, and that would be wired to servo on is pin 40. Now what's on pins 25 and 26? We had said 25 and 26 was the brake, and pins 29 and 30 was the current limit or torque limit output, so that's CLT. And then back here in the wiring check I can also see that I've got CN1, pin 25 and 26 is brake, and current limit output pin 29 and 30. Encoder feedback is the same for every application, and it's PAO, PBO, PCO, 33, 34, 35, 36, 19, and 20. So that finishes up my labeling. Now what parameters have been changed? You can see a summary of that in the Edit Parameters screen. Look at Edit Parameters. Differ from Constant tab shows which have been edited. And so this is a good reference to see what's been changed from default. I would have called this tab Change from Default. Here's what I'll do to check out the operation on the demo. Start with the wiring check and be sure that my 10 volt command is giving me 3000 RPM. So I'll pull up the wiring check under the monitor menu again, and I can see that right now I've set my VREF input to approximately 10 volts, a little bit under, and I have a little bit under 3000 RPM. Second one says I'll use motion monitor to confirm that the 10% torque limit in both directions activates. So I'll move this wiring check over, and we'll take a look here at the internal torque reference. And so now I've got the motor running at a slow speed, and I'll apply torque to it. You can see that the internal torque reference really can go up high as I apply more friction to the system. But if I turn on pin 46, PCL and NCL, so there you see it went from high to low and it's on. Now when I apply that same torque to the motor, it caps off at 10. And also notice on the right hand side that the current limit went from low to high. So there it is without. Now I'll go to 10%. Current limit goes high. And that's how I can tell that this is working. The next one down here is to observe output SO1, which on our demo here is labeled V comp, velocity compare. We're not using it as a velocity compare, we're using it as the brake output. And so the brake should release and that output should turn on when the servo is off. And when I turn the servo on, now the servo has control of the motor and the brake should be released. So we can use the wiring check again. And I've got the motor stopped. And you can see the brake is released right now because the servo is on CN1 pin 40. So now I'll turn the servo off. CN1 pin 40 goes high and the brake output reads braking. There it is, servo on, brake release, servo off, braking. The next one down here is to confirm PN212 by setting the command speed higher than 3000 RPM. So let's try that now. We can look at the wiring check again. And we've got overspeed of encoder output, pulse rate. We went too fast. And in fact, I can look at this alarm and see exactly how fast the motor was going. It was going 3298. So our maximum speed was 3000 and 3298 is what it actually let us go up to. So we can see how that is related to the setting of PN212, that output resolution. So I can turn down the speed a bit and then reset that alarm. And we're back in business. And now finally we want to observe how the motor stops at an over travel compared to servo off stop. So if I hit the positive over travel, the motor stops very rapidly. Whereas if I hit servo off when the motor is moving, still stops rapidly, but not so much. And just to display this stop mode difference graphically, I have prepared a trace. Setting this up is outside the scope of this video. But with alarm stop, you can see that motor is running along here at a fast speed, and I just turned off the servo, and the feedback speed just reduces here according to the dynamic brake. Whereas with over travel stop, you can see the speed decreases much faster, and that's because of the negative torque here you have in purple, which is causing the motor to decelerate. And so I'm confident now that I have set up this control mode application for speed mode correctly, at least as pertains to this application story, which granted has been distilled to exactly what I need. But if you can find this information, you see how easy it is to get this done using the SigmaWin Plus wizard.